This video is for section 10.1, day 2, and I want to start off by looking back at the vertex form for a quadratic function. We used this format a lot last chapter. In fact, you used this on your parabolas project where you had to take a picture of a real-life parabola, write an equation in this format, and really analyze how the a, h, and k affect the parabola. So just to recap that, the a can affect the parabola in 3 ways. First, a, if it's negative, can cause the parabola to reflect over the x-axis. That means the parabola was facing up and then it got reflected and is now facing down. If a is greater than 1, that will cause a stretch, which means the parabola will get skinnier. And lastly, if a is less than 1, that will cause a shrink, actually cause the parabola to get wider, squattier. Okay, let's look at the h now. The h can affect the parabola in by making that have a translation left or right. Okay, and the k affects the parabola by translating it up or down. Okay, so that's just a recap of something we did last chapter. I'm recalling it now because it's extremely similar to radical functions and how they are moved around. The radical function formula I introduced to you yesterday is like this. Whenever x, your input, is under the square root, you know you're dealing with a radical function. Look how similar the radical function formula is to this vertex quadratic function formula. Extremely similar. So we're going to see that a, h, and k affect the radical function very similarly to how a, h, and k affect a parabola. So for a radical function, a can affect the radical function, which remember is a graph that kind of looks something like that, in 3 ways again. If a is negative, that will cause a reflection over the x-axis. Okay. If a is greater than 1, that will cause a stretch. And lastly, if a is less than 1, that will cause a shrink. Okay, so a does all the same things it did before. H also affects the radical function the same way it did with the parabola. It will be a translation left or right. Okay, and k, again, it's going to be the same as a parabola. K will cause the shape to translate up and down. Okay, one additional item I want to talk about is the a can be made negative, which would cause a reflection over the x-axis. The x could also be made negative, which will cause a reflection over the y-axis. So the y-axis will be acting like a mirror if x is made negative, and if a is made negative, the x-axis will be acting like a mirror. Okay, so we're going to look at radical functions that have a, h's, and k's in them, and we'll see how that affects how this shape looks. All right, first example. Graph g of x equals negative square root of x minus 2. and compare to the parent radical function, the most plain Jane radical function out there, f of x equals square root x. So based on what I'm seeing here, I see that the a is negative, so I'm going to expect a reflection over the x-axis. The h is a -2, but when you pull it out of the equation, it's actually a +2, so that's going to cause a translation. Now, if h is a +2, when we're talking about the coordinate plane, the positives are this direction, so it's going to be a translation left 2. So I'm going to expect these two things to happen when I graph. Now first, I'm going to graph the parent function. Okay, remember that I cannot plug any negative numbers under the square root, so I'm going to first plug in 0. The square root of 0 is 0, so here's my first point. The square root of 1 is 1, so 1, 1. The square root of, let's go 4, that's a perfect square. 1, 2, 3, 4. The square root of 4 is 2. Connect those points. That is f of x, the parent radical function. Now I want to graph g of x, and these are the changes I'm expecting to see. Okay, but I should also make an input-output table to get exact points of g of x. So I'll make my input-output table right here. Okay, remember that I cannot have a negative number under the radicand. If I plug in, for example, a 1, 1 minus 2 is a negative number, so I can't plug in a 1 for my input. The smallest input that I could possibly plug in is a 2. 2 minus 2 is 0. 0 is not negative, but it's close to the negatives. My smallest input I could possibly plug in is 2. So plugging that in, 2 minus 2 is 0. Square root of 0 is 0. A negative in front of a 0 doesn't matter. My output is 0. Okay, let's also plug in a 6. 6 minus 2 is 4. The square root of 4 is 2, and then you put the negative up front, and you get -2. Okay, I could also plug in an 11. 11 minus 2 is 9, which is a perfect square. The square root of 9 is 3, and then you throw the negative up front, and you would get -3 for your output. Okay, notice that I tried to choose inputs that were going to give me perfect square whole number outputs. Okay, so plotting these points, 2, 0, 6, -2, and 11, -3, be way down here. Okay, so here is g of x. Now, does what I visually see match what I predicted to see in the beginning? Well, did my radical function get reflected over the x-axis like a mirror? Yes. And was it also translated left 2 spaces? Yes. So what I expected to see is what I actually saw when I did my input-output table. All right, last example here. I have g of x. It's a radical function. Describe the transformations from the graph of f of x equals square root x to the graph of g of x. Here's my parent plain Jane radical function, and they're wanting to know how will this change from here to here. Okay, well, just looking at each number here, I've got a negative added to the front of my problem. Remember, a negative a will cause a reflection over the x-axis. Okay, the 2 here, 2 is bigger than 1, so this is not going to cause a shrink, it's going to cause a stretch. Anytime your number here is greater than 1, it's a stretch. Okay, there's no negative in front of my x, so I will not also have a reflection over the y-axis. My h, when I pull the h out of the formula, it's actually a positive 3, which will cause a translation left or right. Well, on the coordinate plane, when you're adding or going towards positives, you go this way. So it's going to be a translation right, 3 spaces. Okay, and lastly, the k. How will that affect the radical function? The k is a minus 2, so it's not going to be a translation up. It's going to be a translation down because of the minus 2. Right, so you will have to do stuff like this on your homework, where you have to know how a, h, and k affect your radical function. Luckily, a, h, and k behave the same way this chapter as they did last chapter when we were graphing parabolas.